Hi everybody, welcome back to this course on internet technologies. I'm Vardan and this video is all about domain name system. The domain name system or DNS is the internet's phone book. It maps human readable names like google.com to machine readable IP addresses like 142.250.182.14. Without it, we would have to memorize numeric addresses to visit websites or send emails, but DNS does more than just websites. Uh, it also supports services like email delivery through records. Importantly, DNS isn't run by one company or server, it's a globally distributed system with thousands of servers around the world, each managing a portion of the domain name space in a hierarchical fashion. This design ensures both scalability and fault tolerance. DNS organizes names in a hierarchical structure separated by dots. Let's take the example of www.cse.iitd.ac.in. That's the website of IIT Delhi. Here, .in is the top level domain, IITD is the second level domain, CSE is the subdomain, and www is the actual host name. This entire name is called a fully qualified domain name or FQDN. It uniquely identifies a system on the internet, including all levels of the hierarchy leading up to it. At the very top of the DNS hierarchy are top level domains or TLDs. There are two main types. Function based TLDs like .com for commercial entities, .org for nonprofits, .edu for educational institutions and .gov for government websites. Other are country code TLDs like .in for India, .uk for United Kingdom, .jp for Japan. These are assigned and managed by global organizations like ICANN with specific TLDs delegated to regional registrars and national authorities. So the DNS works like a tree. It's hierarchical and distributed. Each name server is only responsible for its own level and delegates lower levels to others. For example, consider the domain dst.gov.in. It's the website of Ministry of Science and Technology. .in is the country code TLD for India. It knows about .gov domains under it. .gov refers to the Indian government departments. It knows about DST, which stands for the Department of Science and Technology again. Finally, DST manages records for its own subdomains or host. This structure ensures that updates and lookups are fast and local whenever possible. Now let's walk through how DNS resolution works when you visit a site like google.com. You type google.com in your browser. Your device's DNS resolver first checks if it already knows the IP from a local cache. If not, it contacts a root DNS server. The server replies that ask a .com server. So the .com server says, I don't know the exact address, but Google's authoritative name server does. Finally, the authoritative server of Google returns the IP address for google.com. Your system then uses that IP to contact Google's server, and behind the scenes, this is managed by DNS software like named, that is the Berkeley Internet Name Domain. So it runs by the name of named in Unix system, and you can observe it using tools like NSLOOKUP or dig. In recursive resolution, the DNS resolver takes full responsibility for resolving the domain name. The client first makes a single request and the resolver contacts the root server, then the TLD, then the authoritative server, all by itself, and finally returns the IP to the client. This approach is typical for end user devices like your phone or laptop because it simplifies the client's job. However, it places more work on the resolver, which must do all the querying and managing timeouts and retries. In iterative resolution, the client handles each step of the DNS lookup itself. Let's say it contacts the root server. The root server doesn't return the final IP. It replies, try the .com name server. Then the client contacts .com, gets another referral to Google's authoritative server, and only then gets the actual IP. This is more efficient for server systems or DNS forwarders that can manage the resolution process themselves. It reduces the load on each DNS server since each only answers for its own level. So that's the end of this video, and in the next lesson we'll learn about Telnet and file transfer protocol. So thank you for joining in, and I'll see you next time.